if you look at how software creation has changed, I mean, even in just the last few years,
Yeah.
it's already dramatic.
Hmm.
But I don't think anything really prepared me for the actual demonstrated reality that you could build a functional, real-time 3D ray tracing simulator
Right.
just by typing a single paragraph of text.
Welcome to the deep dive.
That ability to turn conversation, or what some people are calling vibe, into a complex tool, that's the new reality check, isn't it?
It really is.
Yeah.
And today, we are cracking open the documentation, the analysis of 12 different applications that were built, completely from scratch using just natural language
Skill
problems.
stack apps in minutes.
Exactly. Our mission is pretty straightforward.
Yeah.
We need to pull out the most important lessons here about rapid prototyping, handling, extreme complexity, and critically understanding the real-world limits. We're moving past the hype.
Right into the details.
The short version, the TLDR, is this. Gemini 3.0 automates these really specialized tasks that before required such deep knowledge of coding frameworks. The real value is it's drastically lowering the barrier to entry for complex logic. And here's your immediate actionable tip from the source material. If you want to try and replicate this, always request standalone HTML files in your prompt.
Why is that?
Because that guarantees the app is immediately testable. It's portable, ready to share, or, ready to debug.
That's such a critical constraint to put on the AI. Because even just a year ago, if you suggested we'd be creating a physics engine or a custom board game just by typing,
Yeah, you'd have been left out of the room.
it would have been dismissed as science fiction. But now that shortcut is undeniably real. The tests we reviewed, they showed some shocking successes, like those physics demos. But we're also going to look honestly at the limits.
For sure.
Especially around browser lag and some of the visual artifacts. It's an honest look at where vibe coding is today.
Okay, let's start with procedural generation. This is essentially code writing code. We're talking geometry and a little bit of fun with this thing called the voxel creatures generator.
Right.
It started with a really simple high-level prompt, just asking for procedurally generated voxel creatures and biomechanical vehicles.
And what's immediately fascinating here is that the AI didn't just spit out static images.
Not at all.
It generated interactive physics. You can create a creature, and then you click a button to scrap it, and you watch the pieces just shatter with really realistic tumbling physics and shadows. It's like digital Lego blocks.
And the system retains conversational memory, which is key. The source asked for a specific item, a retro Polaroid camera, and Gemini just generated a fully recognizable voxel camera in seconds.
So it's handling both random generation and specific instruction at the same time.
Yeah, inside a 3D space. It's pretty amazing.
We also saw the process of converting a flat 2D image. I think a Michael Jackson photo was used in the test.
That's the one.
And turning it into 3D voxel assets. So the AI has to analyze the composition, identify elements, figure out depth, and then output 3 distinct 3D scenes.
Setup, mid-event, and aftermath. It's complex scene interpretation.
So what was the quality like?
Well, the assessment was interesting. The results were described as simplistic, but actually really cool. They weren't photorealistic, but they absolutely captured the essence of the image and its movement.
Okay, so let's unpack this a bit. When we look at that voxel generator, the source noted a small, sort of rough edge. The app keeps the same color palette from the last design until you do a hard refresh. What does that color palette stickiness tell us about where these generated apps are right now?
It tells us that generated apps often need iterative refinement. The foundation is there, but state management still needs a human review.
And now we have to move into the really deep technical stuff. We asked the AI to handle a task that is just notoriously difficult and computationally expensive: real-time ray tracing.
And ray tracing, for anyone unfamiliar, is the rendering technique that simulates exactly how light bounces through a scene. It's what gives you those hyper-realistic reflections.
Usually requires high-end gaming hardware.
Oh yeah, and historically, weeks of highly specialized manual coding to set up the geometry and the physics.
The prompt was intense. It specifically requested a 3D ray tracing app in a mirror maze using PBR materials and high-end frameworks like Three.js.
Okay, let's quickly define that jargon. PBR, that's physically based rendering.
Right.
So digital materials that react accurately to light, like real metal or rough plastic. And Three.js is just the standard library for creating 3D graphics in a web browser. The AI had to seamlessly integrate all of that.
And what it delivered was, well, a fully navigable 3D environment. You have these floating metallic pieces where the reflections update dynamically. Light bounces correctly between 3 different light sources. That is a massive computational load.
Achieved via conversation. Now, the source was honest. There were visible artifacts, some small alignment issues, a bit of visual glitching, but for something generated conversationally in minutes, the quality is truly remarkable. I mean, that's the moment of wonder right there.
I genuinely did a double take when I saw the metallic reflections. It looks like a high-end tech demo from maybe 5 years ago, but it was generated from a paragraph of text. That's a huge leap.
It is.
Alongside this, we saw the dot matrix image converter. You upload a photo, and the app turns it into thousands of individual dots.
And the interactivity is key there.
It is. You can apply effects like data glitch or implosion, and you watch the dots move around in 3D space and then perfectly reassemble.
But if the output is visually glitchy, as the source said, how much time does that really save a developer? Is vibe coding just creating complex but, broken starting points?
Well, it showed AI can handle the advanced real-time rendering physics. That complex structure, which used to take weeks to set up, is now instantly accessible.
Next up, we tested complex multi-body simulations. This is where you really stress the math capabilities of the generated code. We started with the particle collider simulator.
Right. The goal was an educational visualization. A particle collider and a tokamak fusion reactor.
And Gemini created 2 separate simulators showing particle acceleration, interaction, and detailed collision paths. The physics here has to be mathematically sound for it to be accurate.
But this is where we hit the performance reality check. The source material really focused on this. It said the simulation runs very slowly in my browser.
But that's because it's doing a lot of calculation.
That performance lag is so important. The source noted that expecting a flawlessly optimized production-ready app right away is the big mistake users make. I still wrestle with this myself, actually. You see this incredible functional output, the whole collider visualized, and you kind of forget that optimization is still a manual, time-consuming step. It's easy to expect immediate perfection.
Totally. And the interactive n-body gravity simulator pushed this idea of complexity even further. This challenges the AI to accurately simulate Newtonian gravity with multiple bodies at once.
Meaning every planet is affecting every other planet all the time.
Constantly.
And what you can do with it is incredible. You can add planets, moons, change their mass, and the simulation just immediately recalculates all the gravitational forces.
Which is how you get those emergent chaotic behaviors, like orbital decay or a gravitational slingshot.
And the AI responded perfectly to requests for cosmic events. You could instantly add a rogue star, a black hole, or even trigger a supernova.
And it all affected the physics in real time. It proved the underlying engine was robust, not just a visual trick.
So when dealing with these high computation tasks, like simulating 10 bodies interacting, is that lag a failure, or is it the ultimate proof of concept?
It's proof of concept. The complex foundation is sound, but performance optimization has to follow the AI generation, not come before it.
All right, so moving away from visual physics, we looked at how this generative capability applies to pure data analysis and real-world utility. The AI bubble research storyboard is. It's a fascinating case of macroeconomics meeting interactive visualization.
Yeah, this one was cool. The prompt basically told the AI to act as a macroeconomist, gather historical data on financial bubbles like the dot-com era, the Great Depression, and then build an animated public dashboard to analyze the current AI market.
And what it created was an interactive macroeconomic analysis tool. It had current AI market data, I think CapEx projections of $405 billion in 2025.
Yeah, and Minsky cycle visualizations.
Let's clarify that. CapEx, capital expenditure, that's the money corporations are spending on physical assets, right?
Exactly, like infrastructure and chips. That number is a critical proxy for massive corporate confidence. And the Minsky cycle just explains the 5 standard stages of a speculative bubble, from displacement all the way to panic.
So the AI didn't just plot data, it applied complex financial theory.
It did. And the highlight was the bubble simulator game that was built into the dashboard. Users could make business decisions, raise funding, hire people, and the chart would update, tracking risk until the demo day bubble popped.
And the tool even provided its own strategic assessment.
It did. It said something like, productive bubble, infrastructure survives, speculators die, banks safe, stocks at risk. That's predictive application, not just visualization.
So moving from macro trends to microanalysis, we have the basketball shot analyzer.
This is a total game changer for coaching and skill development.
The workflow seems simple. You just upload a short clip of a jump shot, and the system processes it frame by frame.
Right, using computer vision. And the technical advantage is just so clear. It delivers this granular biomechanics, breakdown joint angles, wrist snap, foot placement.
It analyzes the entire kinetic chain and gives you a shot score and even a pro comparison mode with skeleton overlays.
So how does that economic bubble game really show the difference between just raw analysis and genuine application?
It turns static data and historical frameworks into a dynamic, educational, and most importantly, a playable scenario for the user to learn from. Our final segment looks at the AI's ability to model large-scale systems and integrate real-time inputs. We're starting with the Earth simulator with weather control.
The prompt asked for a perfect 3D Earth globe. Realistic, interactive cloud layers, high-quality rendering.
And it delivered a rotatable 3D Earth where you can actually adjust environmental parameters, CO2 levels, temperature.
The satellite feature was particularly impressive, I thought.
It really was. The system calculated and displayed the correct orbital paths for communication and weather satellites, all moving in their actual trajectories.
Then that's hard. That requires accurate geospatial calculation with real-time physics. It's not just a visual.
And you could use natural language commands. You can type trigger a Category 5 hurricane, and the system updates the visual state.
Amazing.
Then we have the hand-tracking fluid dynamics simulator. This one is simpler. It just tracks your hands with a webcam to create these swirling, fluid, dynamic effects.
The appeal there is just demonstrating that real-time computer vision integration with generative effects. It's the basis for future gesture-based interfaces.
And finally, the power of 10 animator. This tested the scaling challenge, generating an animation zooming all the way from a cosmic scale down to an atomic scale.
And Gemini did this by coordinating with another model, Nano Banana, to blend the imagery across those different magnitudes.
And that ability to coordinate specialized subtasks, telling one AI to handle image generation and another to handle the animation, that's the next huge leap.
Though we do have to acknowledge the honest check, the content accuracy. It varied. There was an odd, unexplained hand artifact that appeared at the cellular level.
Right.
So the concept of AI directing other AI worked, but the final polish still needed a human eye.
So what's the overarching lesson from combining vision, physics, and image generation across all these different scales?
That the AI can successfully coordinate specialized subtasks and separate models to achieve these really complex multimodal results on a grand scale. When you look back at all 12 of these applications, I mean, from the Monopoly board generator, which we didn't even have time to get into, to that high-end ray tracing demo, the impressive part isn't any single one of them.
No.
It's the sheer totality of it, the diversity and the complexity. 12 functional applications built through conversation in a matter of minutes.
That amount of work would have required significant development time and specialized expertise just a few months ago.
Multiple teams, probably.
The ultimate unlock here isn't just speed, it's the democratization of high-end tooling. The code is still complex, but the barrier to accessing that complexity has been, just vaporized by conversation. So the real question then isn't whether AI can build perfect applications today.
It's whether AI can make building useful, structurally sound things accessible to significantly more people. And based on these results, the answer is, it's an undeniable yes.
So if the AI handles the complexity, does the value of the human developer now shift entirely to optimization? Or does this finally mean we can move beyond the screen and start building truly custom interfaces applications that just weren't worth the coding effort before? The tools are here today. What kind of complex logic or creative idea that you previously thought was impossible to code are you now ready to prototype? That's something fascinating to consider as we wrap up this deep dive.